Welcome, everyone. We'll get started in a couple of moments. Just a couple of disclaimers to put out there. The session is being recorded and will be available for view on demand after our time together today. So if you do not wish to participate in a recorded session, please ask you to disconnect now at this point. All the attendees are going to be placed in silent mode during today's session. However, you can and are encouraged to ask questions directly here in the Q&A tool in the Zoom platform, as well as across social media using hashtag UrsaLeo_IIoT. Once again, that's hashtag UrsaLeo_IIoT. And we'll get started in just a couple moments. Thank you. Good morning, good afternoon, and good evening, everyone, and welcome to today's virtual conference, How to Decrease Costs, Improve Safety, and Reduce Environmental Impact Using 3D Digital Twins, brought to you by IIoT World and sponsored by UrsaLeo. I'm Greg Orloff with IIoT World, and on behalf of my global team, speakers, and sponsors, thank you for joining us today. We will be monitoring the online social channel, so feel free to send in your questions and thoughts in the Q&A section of the Zoom tool here, or via social media, Twitter and otherwise, using hashtag UrsaLeo_IIoT. That's UrsaLeo_IIoT. If you do so, several of the most active participants today will become lucky winners of several prizes that we're going to be awarding later on. The first will be an NXP ultralight-based hardware kit with 9 sensors valued at $550. And the second giveaway will be a Raspberry Pi-based kit with 9 sensors valued at $175. And in addition, Alientia will also be giving away a free 12-month development license, good until New Year's Eve 2021, to the winner of the Raspberry Pi kit. This has a list price an additional $500. So definitely get engaged and bring forth your questions and interact with us here today. So before we dive into today's material, please allow me to give those of you who may be joining us for the first time a little bit of background. IIoT World is a digital media publication that covers the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that are shaping the industrial Internet of Things. Analytica's 2020 report ranked IIoT World as the #1 global brand for industrial IoT. And IIoT World was also recently ranked by K-Core Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Additionally, smart cities has been in the top 5 positions for several past years. And our mission is to essentially help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and the CXO decision makers who seek these solutions. Today we have a session covering a complete end-to-end manufacturing solution that combines data collection using Alientia's 5,000 plus drivers for common industrial devices and UrsaLeo's photorealistic 3D digital twin technology to display the data. Collectively, the combined solution decreases costs, improves safety, and reduces environmental impact. So the key topics that we're going to discuss today include how fast access to IIoT sensor data is key for delivering an industrial digital transformation in any sector, how to overcome brownfield operational technology integration difficulties for different devices, technologies, sensors, and machines, and how to market the leading UrsaLeo and Alientia IoT integration solution makes machine information quickly available through thousands of ready-to-use drivers, a wide variety of connectors supporting administrative software as a service, and how to complete the architecture with strong cybersecurity features and O&M solutions for larger scale IIoT deployments. I'd like to welcome our first speaker today, Mr. John Burton. John is the CEO of UrsaLeo. And before starting the company, he spent over 30 years in the semiconductor industry, working with industrial customers across Europe, North America, and Japan. And seeing the vast quantities of data being gathered in the IIoT environments, he got together with Angie Stitcher, an ex-Apple person, to find ways to better visualize and use the data, hence the birth of UrsaLeo. So John, welcome today. The floor is yours.
Okay, thank you very much, Greg. So I will first turn on my video so everyone can see me, and then I will share my screen. Okay, so as Greg has said, the theme of today is using 3D digital twins in an industrial environment, specifically a manufacturing environment, to reduce costs, improve safety, and reduce environmental impact. So before we go into the presentations, I just wanted to start by kind of showing what we mean by a 3D photorealistic digital twin. So hopefully on your screen now, you can see a small manufacturing environment. This is created in the Unity gaming engine. So this is running on gaming technology. This can be displayed through a web browser. It can be displayed on an iOS, iPad native application, on an iPhone, a virtual reality headset, an augmented reality headset. So this is able to be deployed to any target that needs to be used in the environment. And this is actually combined with live sensor data. So I just zoomed in to a sensor reading that's showing the amount of carbon dioxide. And this is data that's live. It's coming from sensors actually in our offices. And if I go over to the temperature sensor, you can actually see that the data is changing slowly. It's just some noise there on the sensor. So every now and then the reading changes. So that is live data. So this is the environment that with the end solution that we're going to talk about today, is getting people into this three-dimensional world instead of the 2D dashboard. And during my presentation, I'll talk about how we can use this environment, this interface to achieve the goals that we've talked about at the beginning of the presentation. However, before we get to the point of actually displaying data in the 3D environment, we obviously have some steps to take first. So before we get to this, we need to talk about capturing data, about creating the 3D models, and then the final solution. So with that, I'd like to hand over to Antonio from Aliantia, and Antonio is going to show how his solution from Aliantia helps companies very quickly go from not capturing IoT data to a full IoT deployment. So I will stop sharing and hand over to Antonio.
Thank you, John, and thank you for inviting me to this webinar. I will quickly show you what Aliantia does and how it helps integrating fast any type of machinery into digital transformation applications. So basically, Aliantia, it's a player well known in Italy and Europe on the industrial IoT. And we have recognized since many years the importance of the IoT backbone that is key for sharing information between, let's say, the south side, so the machineries, the sensors, the plants, and the industrial systems, whether they are, let's say, in a factory, outside the factory, anywhere. So these are all information providers that whose data can be used by many applications in different situations, like within the factory, across a supply chain where you have multiple tiers that would like to combine information for just-in-time delivery and quality management, and also for the connected product. So the smart products that combine physical things with the digital counterpart. The way Aliantia address this is through a software that is a pure on-edge software that basically is compatible with almost 90% of the industrial devices around, and does three things, and does three things very, very well. And then the things are done, the three things we do is first, talking with devices in a way that is zero coding, does not require any coding, uses what we have, what we call the device driver that provides quickly, in a few seconds, the information from the device to the software. We have more than 13 protocols supported, and we have, as John said already, a library of more than 5,000 drivers, and with the tools that also enable any customer system integrator to create its own driver. So this is the first step in creating a digital twin. Then what our software does is augmenting the information where we can add rules, we can add the variable, we can add algorithms in a way that is, let's say, agnostic to the user, to the end application. And third, we have a series of connectors. So for on-cloud applications and for on-prem applications that enable any developer to have its own view of the digital twin, so the runtime view of the machine in the way he likes more. So, and then we see more information here next. So, three things done well. The software runs on Linux, Windows, Docker, virtual machines, and we are working with several partners here to deliver complete solutions. So, like for Advantech, the Cisco, Stratus is a late recent partner for fault-tolerant solutions, also Dell, virtual architectures and physical architectures. The way we work, we cover the IoT backbone. So from the machine to the connector to the application. So we work with the certified application partners. UrsaLeo is our first US partner, and actually use the information we can provide to implement end-to-end industrial digital transformation solutions. Then we have system integrators, some of them also operating in states, also operating worldwide, that are capable to deliver complete projects using the IoT of Allianzia, and then a global partner. So the way we go to market, especially, is with friends, with partners, as we believe strongly that Industry 4.0 is a collaboration exercise. So well recognized by analysts. Recently, we got new recognition by Frost & Sullivan, but also Gartner has covered a lot about Allianzia. And in terms of where we use the solution, we have done several, hundreds of projects, most of them done by our partners, but also we've done the largest projects directly with the customer, and this covering automotive sector, bottling chemical sector, the energy, and also transportation, where the asset connected is the ship. The ship with all this equipment inside, and with the navigation information, many other information. So if you dig down in the customers, the way they use the information is first, industrial customers wants to increase productivity and control the operational efficiency. So that's the case, for example, in Bosch in Italy, where they've used the Allianzia software to cover a good portion of their plant, for pumps plant production, to monitor and increase OE, and now moving on the predictive maintenance and doing, let's say, a second step, because also the digital transformation is not something you do as a one time. You start and then you improve, and it's a continuous improvement also type of exercise where you discover also the way to use information. Brembo was our first big customer. Now our solution is deployed in 5 plants around the world: China, Mexico, Eastern Europe, and Italy, for many things now, including predictive maintenance. And Ansaldo is probably one of the toughest projects we went through, predictive maintenance for high-tech production of very, very important components in the turbogas turbines. And again, predictive maintenance and predictive quality is very important. And lots of data, high-speed data, and algorithms developed by our partners here. So what's inside the box? So we have a fully configurable software gateway that's capable to get data from the machine in real time. We have lots of flexibility in configuring when, how fast data should be collected and exchanged with the machines. and then connectors to applications, wide, very large variety of connectivity options. Everything, everything is available. There is no cost. I mean, all the southbound connection is included in the product, and we have a large variety of ways to options for CNC, PLC, robots, and other devices. So if you have the driver for the specific device, it takes 10 seconds to connect to a new device. Just specify a name, specify an address, and that's it. Green is connected and data is available. The driver has already the data sets that can be then configured. And I will speak what happens if you don't have the driver available. We have, as I said, many connectors. UrsaLeo chose to use the MQTT. MQTT, our implementation supports full cybersecurity for encryption of communication, and has been tested also with satellite communication in many bad situations, so it's very, very reliable. And the interesting thing that our solution has is the possibility to have multiple connectors from the same software, and every connector can be configured to have different data sets with different speeds and different ways to communicate to different applications. Everything documented, and so there is a data contract associated to each connector configuration that then can be shared with the customer and say, okay, we agree to exchange this information in this way and with this frequency. Now, the core of our solution is what we call the driver. Driver is available in this global repository we call Library of Things. The customer can also have its own private library. If you go to cloudallianza.com, you can register and then access to the library. You see what we have available, and eventually use it freely. What is in a driver? We have several things in a driver. The protocol, of course. So the driver says to our software which protocols has to use to communicate with the device. The setup parameters, and I will show some example, which data should be exchanged. And then you can add the rules. So control logic, alarms and events that are also based on rules. And then you can also, within the data set of the driver, you can have also user manuals and instructions that are stored in the library. So these are examples of the parameters. You can set up speed of collection. You can set up if you want to get data from a serial line, Ethernet, and then other different options, managing also versioning of the driver. You can import data through Excel and to different ways to make it very speed. So this is an example of data. This is a S7 by Siemens PLC. So some will be familiar with the data block and the way we use here to get the information, setting the address and setting the Boolean, what type of Boolean data. And then you can build alarms that are driven by, for example, thresholds. You can set up expressions to create new alarms, or you can also create rules to create new variables. And then on the variables, you create a new alarm. So there is a powerful set of possibilities to create additional data from additional logic on top of machine data, even combining multiple data from multiple devices. What we are going to add here, and this is the way we introduced the 3D modeling, is things we are working to expand the driver concept, so including complex calculus, for example, derivatives, integrals, for example, useful to understand the heating trend in a industrial oven, or 3D modeling, and this is what we're talking today, adding 3D views of devices so that applications can have also the 3D views of the thing that they are monitoring, and then adding maintenance plans and KPIs. Our objective will be to have OE in a box, where you get the machine, you get also the OE calculation, but also you have a reference OE for other users, so you know where you are in the efficiency in the use of your machine. And so this is what we are doing regarding 3D, and this is the work we are doing with trace parts, and showing that we will add the 3D model together with the data sets, together with the instructions to use, and also having this information available in the repository and available to any user of our drivers. And having said that, I pass the ball to next speaker. It will be Gabriel. Thank you, guys.
Thank you very much, Antonio. Let me share my screen. So I'm Gabriel Gig, the CEO of Trace Parts and one of the co-founders of Trace Parts. Okay, now you can see me. I'm based in France and happy to be here today to explain you why Trace and what Trace Parts is all about when it comes to designing and saving time. Okay. Share. Okay. So Trace Parts is a huge repository of 3D catalogs. We have to date more than 1,000 and close to 1,100 different catalogs. And our web application is also available and working on mobile devices. We position ourselves since the very early 90s as being an interface between the part vendors, going from mechatronics to electronics, electrical, mechanical, hydraulics, and pneumatics. So we are an interface between those vendors and the engineers and the designers who need to save time and to have a huge productivity savings when designing new machines, new products. And by using the digital twins of these physical products, we are generating leads opportunities, sales leads opportunities for these part vendors and any of the industrial players, going from software vendors to 3D printing or computer hardware, who at what point of their sales and marketing activities want to reach designers and engineers. So through the last, during the last 30 years, Trace Parts has been fulfilling and replacing tons of paper catalogs. Then during the years 2000, there was this frisbee marketing trend of every supplier of industrial parts having their own CD and then DVD, then USB sticks with data. And Trace Parts, since about 12 years ago, since Trace Parts has developed a unique portfolio of services. Everything is based on a secured data vault where Trace Parts is offering and saving the product information from industrial catalogs. And we are offering different content syndication capabilities. We have a very rich documented API for partners like Alliancia, being able to syndicate this content without even having to jump to Trace Parts website. And ultimately, we are generating sales lead opportunities for these industrial players. Trace Parts belong to a French organization called Group Trace. And within this holding company, we have a sister company called Green Systems. They are involved in the smart thermostat and smart energy savings using very sophisticated dashboard and and sensors to capture and to optimize the consumption of different energies. Beam & Co is also known in the field of building information modeling data, and they have a nice application to manage this data. And Trace Software is also one of our sister company in the field of electrical calculation, solar panel for the calculation of solar panels, the optimization also of electrical applications. Trace Parts is physically present on 3 different continents: in China, in Europe, and in the USA and in Brazil. And altogether, it's more than 80 people working for Trace Parts to date. All the Trace Parts business model and value added for industrial players like many of you today, it's based on unique metrics that we have achieved and completed over the last 30 years. We have more than 1,000 catalogs. Sorry, we have over 4 million registered users, designers and engineers from many different countries. And they are visiting the website and using the website again as a huge productivity saving for their for going to market and releasing their products and machines and new design faster, with less risk of doing errors by remodeling and redesigning the industrial parts, the catalog parts, and the standard parts of their machine. So we are not only a productivity savings for all the designers and engineers, but also we increase the quality and the safety of their machine design. All of these metrics are audited and certified by a German organization called IVW. So it's not just our web metrics, but it's certified and audited. We have a mobile application, but to be honest, it's not convenient to do a machine design on a tablet or even on a smartphone. So this is more a marketing tool. And we have also participated some years ago into this Frisbee marketing era by distributing hundreds of thousands of Trace Parts DVD. The Trace Parts EasyLink solution is a way for our customers and partners to syndicate the Trace Parts catalogs with their own white labeled, let's say, look and feel, with their own user experience. And doing that, we give the possibility for these customers and partners to not have to reproduce and repurpose on their own website. They can really, using the API or using an iframe, they can repurpose the digital twin digital mock-ups of these physical products. The Trace Parts Publishing Network is a unique marketing exposure for all the industrial suppliers who are giving their catalog and publishing their catalogs onto the Trace Parts platform. And all of these players that you see on these charts are either software players in the field of computer-aided design or computer-aided engineering or manufacturing or 3D printing or engineering medias. Any media that is targeting engineers and designers, whatever the country, is potentially a partner for us to syndicate the Trace Parts catalogs and the digital twins of these models. And just to finish with, before focusing on the Alianza partnership we have, so Motion Industry is one of the key players in North America for the distribution of mechanical and automation products. And the digital thread strategy that we have implemented with them is to not only offer the 3D geometry and the 3D dimensions of their products, of the products they distribute, but also to embed rich product attributes like the buy now link, like of course the part number, like the full description of the product. And all of this rich metadata form the digital thread that is the continuity of the digital data related to the product from the search to the usage into a new machinery design. And all of these rich metadata will guarantee that together with the digital mockup of the product, all of these product specification will go along with the project. And once the machinery design is completed, using any of the supported CAD software, and we support more than 70 different CAD software, going from SolidWorks to CATIA to ePlan and many others. Once the machinery design is completed, then the designers can output the bill of material of his machine, and all of this metadata will be a great support when it comes to buying and purchasing the parts. Just talking specifically about Alianza, the partnership is like was shown in the previous presentation, to seamlessly enrich the Alianza metadata by having 3D preview, live 3D preview powered by Trace Parts, and also the CAD files download capabilities without having the user to be redirected to the supplier website or even to Trace Parts website. It's a very seamless integration, and it enrich the offerings from Expango, this library of data, and we are very happy and very proud to be part of this partnership. Thank you very much, and I will be happy to answer your question after the presentation.
Okay, thank you very much, Gabriel. So now we've heard a little bit about how to collect the data, and we've heard how the 3D environment can easily be created. I would now like to show how we can pull the whole thing together, hopefully into an actual useful product that's going to achieve our goals of cutting costs, improving safety, and reducing emissions. So we've already heard from Alianza about the seamless way that they can gather data from an industrial environment using their huge library of drivers for common industrial machinery. We've heard from Gabriel about the massive library of CAD designs that Trace Parts carries. When we combine those things, we can generate a 3D twin of a complete manufacturing environment. And the screenshot I show here is a mock-up of a factory floor that we've created, but it's using common industrial machinery from companies like Siemens. And hopefully we've already demonstrated that it's pretty quick and easy to get from the real environment to this digital twin environment where we have the CAD data, and we can create this model very, very quickly. So what UrsaLeo does is, once that model is created, we start combining the 3D model with real-time data and data from other sources. So on the screenshot, you can see that there's various sensor readings, and I'll at the end show again the live version of this. But we're pulling in that live sensor data, we're combining it with a 3D model. We can also pull in data from lots of other environments, such as maintenance records, installation data, historical data, to basically give the operator a complete digital design center, which shows everything that's going on in the real-time operation of their facility. So how does that actually go about doing some of the goals? So once you have this environment, we can enable things like remote maintenance. When a problem occurs, we can triage it very quickly because we can actually display the problem on the 3D environment, so we know exactly what happened and where it happened. And then UrsaLeo provides a collaboration mode where a remote staff and on-site staff can share this digital twin 3D model to actually triage the problem in real time. So the person on site can be looking at the 3D digital twin on an augmented reality headset, whilst collaborating with remote staff, remote experts, going through the maintenance process. So this removes the need for on-site visits. One of our initial customers is actually in the oil and gas industry, logistics. They expect to save 10 to 15% of their maintenance costs, which for them is a saving of around $5 million a year, purely because they're not having to send staff out to sites. They're able to collaborate remotely. We also work with wearable technology to track people's position. So operators can show where they are in a facility or where they are on a site. We can also detect if they've tripped, stumbled, fallen. There's an SOS button. There's live communication, walkie-talkie, and video. So this allows us to improve safety and actually reduce insurance costs, because we can provide a real-time view of where people are, what they're doing, and have they been impacted in an accident. And then finally, we can improve efficiency. Over time, you can gather data as to where people and things are in the 3D environment, and then use that to look at efficiencies, how goods and people are moving through a facility, where the bottlenecks are, where efficiencies can be improved, really replacing the old paper time and motion type studies. Very quickly on the architecture. So data comes into a cloud. Obviously, that data is typically gathered by Aliantia and is transmitted over many different protocols. We typically use MQTT. We also take in data from other cloud IoT platforms such as AWS, Azure, Siemens, and we combine all of that data into a single view in the cloud. So the 3D model and the sensor data is sitting in the cloud, and then it's delivered to whoever wants to look at that data, obviously based on credentials. And that data can be viewed through a web browser. It can be viewed on a virtual reality headset. It can be viewed on an iPad, an augmented reality headset. Everybody sees the same thing at the same time. So as new sensor readings come into the cloud, that information is updated to all people viewing it at the same time. And this enables the collaboration feature I just talked about, where we're able to share that cloud information, share that digital twin between the person on site and the remote person. We've talked a lot already about creating models. So CAD files is typically the starting point for equipment. We also use things like photogrammetry, which is taking lots of photographs and stitching them together, and LiDAR scans, and that's typically used to scan the space that the equipment's in. We can also work from architectural files. So there's many different ways of creating these 3D models and these 3D environments. But in the last few years, the gaming industry, the film industry has really driven forward 3D technology to the point that it's very, very easy to create 3D environments and 3D models. We can do enhanced visualizations on top of the basic digital twin that shows a recreation of the physical thing. There's lots of things you can do in the virtual world that you can't do in the physical world. And so these are some of the advanced visualizations we're delivering to customers. Things like zooming in and zooming out for more or less information, X-ray to look inside pieces of equipment, fluid flow, so seeing how fluids and gases are moving through pipes. Internal views, so I've shown here an exploded view where a piece of equipment flies apart into its component parts. Very convenient for showing how the internal operation works, looking at sensor readings inside pieces of equipment. And that really falls out of most CAD designs. CAD designs are put together by putting lots of different components together. We can take that CAD file and make it expand to show the internal operation. And then, as I've already mentioned, we track moving objects, moving people to show real time where people are, where things are, and how things are moving through the facility. Because we have a spatially aware data model, we are able to do inquiries using the 3D environment. So very convenient to be able to say, show me all the pressure readings within 50 feet, or show me all the temperature readings on this pipe, all the pieces of equipment attached to this pipe. So those sort of advanced inquiries of data, making use of the spatially aware data model, making use of the 3D environment to much more complex ways of looking at the data in the facility. Lots of data can be brought up. We can hide almost infinite amounts of data behind the 3D model. So that allows us to have data sheets. It allows us to have maintenance records, historical records, all of which can be pulled up at a click of a button. And that's bringing data from many, many different databases into a single view. So that really accelerates the efficiency of operation, as opposed to having to make queries of multiple different databases when a problem occurs. This allows all that information to be pulled up from a single source. And then collaboration mode, I've shown here a picture of RealWare. That's our partner in the AR space. They make a ruggedized Android-based head-mounted computer. We're working with them to display digital twins and live picture-in-picture video on that display. So this is where somebody working on site can collaborate with somebody remotely. They can bring up the digital twin, they look at sensor readings, they can go into a guided mode where one person's controlling the viewpoint, the other person's seeing the same viewpoint. They can communicate using video and voice, enabling the whole area of collaboration and remote maintenance. And then rewind, record, and replay. So very often if something happens, you need to generate a report. This can be for internal reporting to management. It can be for insurance purposes. It can be for regulatory purposes. So we allow the idea of going back in time, selecting what you want to look at, and then generating a virtual video through the event you're interested in. Also, this is how we generate time and motion studies using wearable technology to accurately track people's position, goods moving through a facility, and over time, generate a heat map showing where things are moving more quickly, more slowly, where the bottlenecks are, and allow simulation and planning of the factory. And this is available on any device. So the browser for a PC or a laptop, a native iOS application on an iPad, virtual reality headset, AR glasses, anything. The technology is rendered using a gaming engine, so it's very lightweight. It doesn't need massive computing power to generate these 3D models. So very convenient to be able to use this on things that are mobile, so people on site can use them as well as people in the control facility. And with that, I'm going to switch back to the actual live digital twin. I don't think everybody was here when we first showed this at the beginning. So this is actually a live data being combined with a 3D model in real time. The data is actually coming from our test lab, but it will be changing slightly as you see the readings coming in. So here's a temperature reading, and every few seconds that's going to update to a slightly different number as the temperature varies slightly. And then I can navigate through to different readings. You can see the sound levels there are changing. We can also show how an alert goes off. So when something happens, Aliantia has generated an alert and sent us the data. We can show that alert happening in 3D. And we can then pull up more data, such as maintenance records associated with that, dispatch somebody to repair, enter the collaboration mode, make a recording and display it. So I think that covers the majority of the presentation today. I'll now hand it back to Greg, and I think we may have one or two questions.
Excellent. Well, thank you, John. Thank you, Antonio. Thank you, Gabriel. You gave a comprehensive overview of the world and quickly evolving world of 3D digital twins. And we do have a lot of questions that are popping up. So I definitely want to transition into our Q&A portion of the day. So just as a reminder, you can submit those via the window here in the Zoom platform, or feel free to send them in via the social channels with hashtag UrsaLeo_IIoT. And we will be giving away those two prizes, or three prizes actually, at the end of the session. So stay tuned on that front as well. So let's kick things off then. We've got a multitude of questions in here, John. Let's see. Frank's got a question. Okay, how do you handle really dense instrumentation twinned into the 3D environment? Is there a layered drill down?
Yeah, so we really handle the amount of information displayed using zoom. So if you zoom out, we collapse the amount of information. So for example, if there's a sensor cluster, a whole bunch of readings in the same place, we'll collapse that down to a single sort of dot. As you zoom in, or as you're zoomed in automatically, if something happens, then that expands. So we can control the amount of information on the screen at any one time. And most of our team is from the gaming industry and Apple. So we're very, very focused on clean UI, intuitive UI. But yeah, it's mostly controlled through zooming in, zooming out.
Excellent. Now Rashid's got a question. And this kind of dovetails into the privacy side of things a bit. It says, do wearable devices, such as the AR devices, do they store any type of encrypted data locally?
They can do. So typically they record the last few minutes. So if, for instance, you have an accident, the wearable device will have information that can be extracted to show how the accident happened. So what you're doing just before, what you're doing after. There's also the idea of bullying and people being harassed at work and being able to use the wearable device to record the event, so they can actually use that. But that's under the user control, and obviously every company that uses wearable technologies has to institute a privacy policy and have the agreement of the staff. So sometimes no personal information is collected, sometimes complete personal information is collected, but that has to be an agreement between the facility and the staff. Got
it. Sergio's got an interesting question too. And this is probably the whole enchilada type of a question, and it's a loaded one. But how fast is it to build a 3D model of an entire industrial facility? A couple of reactors or maybe some auxiliaries as well. Any insight into what that lead time would look like? So if we have the CAD files, and TraceParts obviously has got most of the CAD files in the world at this point, it's very quick indeed. From CAD to a 3D model is a couple of days, a week. Basically, it has to be pre-processed a little bit, add lighting, texture. So it's a fairly automated process, minimal human intervention. It can be done in a couple of hours, but we usually have a backlog. So let's say, a week is a reasonable time. Sometimes the space that the equipment in takes a little bit longer. If we have the architectural files, they're usually in what's called a Revit file, which is a common architectural CAD design. Again, very, very quick. What we find is facilities don't always match their architectural files. So there may be some additional stuff needed, a wall's been put up since the design was done, and that has to be added. But usually a week to 2 weeks, I think, to go from zero to a complete facility. It's impressive. Now, I'll throw in the curveball into that, the proverbial one. What if you run across that flux capacitor that's not something that doesn't have a model file? What's the approach for a situation like that? So photogrammetry and LiDAR scanning. Photogrammetry is how Google Street View works. So it's just literally taking a lot of photographs and then stitching them together so they form a seamless view. So you can use that. You can just take a lot of photographs of a piece of equipment. You can use a laser scan, which is more accurate from a positioning point of view. The problem you're going to run into perhaps is you don't get the internal workings. So you can make an external scan, but without the CAD designs, we can't get inside. So that would be the limitation. Got it. Now, this is more of a, I guess, sewing it all together type of a question from Dirk. How is UrsaLeo's solution connected or integrated with Alianzia's? Maybe if you could just walk us through that, how everything dovetails together, that might string it together for everyone, John. Yeah, so we start in the cloud. So we start with data arriving in the cloud. Alianzia really makes that data get to the cloud. So Alianzia, if you're an industrial facility and you want to get connected, Alianzia out of the box gives you drivers for almost every possible piece of industrial equipment. And I've actually been through the process of setting up Alianzia's software and sending data. It took me from literally not knowing the software at all to getting data into the cloud about 35 minutes, 40 minutes. So that's kind of the how quick you can go from not sending data to the cloud to having data encrypted for a driver for your piece of equipment, knowing the different sensors in that piece of equipment, sending data to the cloud. Once it arrives in the cloud, that's where we take over. So that's where we bring that data in and combine it with the 3D model. So the two solutions are completely complementary and synergistic. One collects data, we then visualize and display the data. Got it. Ernest is asking, how does network modeling and simulation like Petri nets play a role in your processes and implementations? I'm going to admit, I don't understand the question. Okay. No, it's just, Ernest, if you can elaborate for us a little bit.
It has the same problem. It's not clear what is the question. So probably we are discovering something interesting. So
yeah, fair enough. Ernest, by all means, if you want to rephrase or retool that question, we're happy to take a look at it again. Yeah, he may be talking about using digital twins for simulation, which is something we don't do at the moment. We're doing real-time operations. We do have customers asking about it. It's a whole new, this is when somebody simulates a jet engine, they have physical models and material science going on. That's beyond what we do at the moment. Got it. How about, Rashid's got another interesting question. How is remote maintenance effective in case of physical sensor failures on critical points? So maybe talk a little bit about that whole aspect, John.
Yeah, so remote maintenance, remote collaboration, it really fell out of the architecture that we adopted, and it was a little bit lucky, I guess, that we adopted this architecture and then realized that this remote maintenance, remote collaboration was a feature kind of built in. So any problem that occurs, you get an alert. You first of all, you've got to figure out where the problem is, what happened. You've then got to pull a bunch of documentation. So you've got the data sheet, the records, the historical records. So you have the context around that alert. One of the nice things about the 3D model is that a leak in a pipe is usually caused by a pump somewhere else. So it's quite easy and quick to figure out what actually is happened. Why is that leak happening there? Let's look at all the pumps attached to the pipe. So once we've pulled that data, then we can get into the remote collaboration, remote maintenance. Typically, if something happens with a piece of equipment, the people on site aren't going to be experts in that specific piece of equipment. They're going to call in the vendor, and the vendor's going to typically send somebody out to help repair, maintain. What we're suggesting is before you take that step, the guys on site collaborate with the guys remotely, and if it's a failed sensor, that typically is going to need a sensor replacement. That might be something that can be done very easily on site. Ship out a new sensor and replace it without a site visit. So all of the maintenance should first, before somebody's sent from what could be a remote headquarters, we suggest the collaboration mode allows triaging the problem, diagnosing the problem, potentially solving the problem much quicker, much more efficient, much more secure, because we're not sending people into hazardous environments. And our guess is, we're still fairly new to this, but we think maybe 20%, 30% of problems can be fixed that previously would have needed a site visit.
I can add one thing about the sensors, that sensors have also diagnostic information they can provide to their protocols. So so we could collect not only the actual sensing information, but also the sensor diagnostic if available. So these are.
Okay, no, I appreciate that. Thank you, Antonio. Okay, Frank's got something from the field. So a lot of their sites are, as he puts it, in the middle of nowhere, and they're based off of a copper run for comms sake. What's the network bandwidth requirements to do an implementation? Where 3D images are stored? Are they moved to the local application so they're not constantly going across the network? Maybe talk to us a little about requirements, John, if you could, and Antonio.
So as long as you're staying away from live video, they're very modest. If you want to have live video, you need kind of a Wi-Fi connection at least. It would work over Wi-Fi to cellular, but it probably wouldn't work on a satellite connection or a really low bandwidth connection. But apart from live video, everything else is very, very low bandwidth once the model is loaded. So the recommendation would be, say you're using an AR headset, load that model into the AR headset memory whilst you're in a fairly high bandwidth environment. And then when you travel out, all that's being updated is sensor readings, maybe chat, but it's going to be very low bandwidth. So it'll run on anything at that point.
Maybe further to that, Radek's asking, what's the split between edge and clouds in terms of the solution? What's going on, what's being computated locally, what's being pushed up and being crunched in the hemisphere, the heavens, so to speak?
Yeah, so like I said, that's a fundamental piece of our architecture, is that the 3D model and the sensor data and all the renderings, that's all being done in the cloud. Not the renderings, all of the heavy computations being done in the cloud. Okay. All that's being delivered to the headset or to the VR glasses or whatever is the information necessary for that headset to do the rendering locally. So the split really is, if you like, the rendering engine, the game engine is on the edge. The content to the game, which in this case is the factory, is in the cloud. Now that model can be run on a local server. The cloud server can be on site, but the person out repairing the piece of equipment is only receiving sensor readings and minimal updates while he's actually out there. So the 3D model piece has been delivered to him already, and he's just seeing some minimal stuff when he's out in the field.
Got it. I know in today's day and age, I don't want to dwell on pandemic-related things, but I think it's a salient point. You talk about asset tracking or resource tracking in general, from people to equipment. Is there any example of tracking workers, positions and related? And Ernest has got a question specifically around safety. But if you could talk maybe to that aspect of this and what can integrate with UrsaLeo would be great.
So the safety aspect for people mostly comes down to integration with wearable technology. So the company we work with there most prominently is a company called Connect Up Technology out of Southern California. They have wearable devices that, position, have you stumbled, have you fallen, SOS button, live video recording. So combining that information with the 3D twin really gives you that safety angle. So you can set up alerts. If somebody falls over, you get an alert, you know exactly where they are. If somebody hits the SOS button again, you immediately get a 3D view of where they are in the facility.
So we've got a couple questions that are popping up here. I'll try and stay agnostic, but in terms of predictive analytics or doing something with the data, what do you have there in terms of integration as well as stuff that, or I should say, capability that Ursa brings to the table directly or through partners?
So Antonio, do you want to take that from the edge point of view, and then I can talk about the cloud side?
Sorry, I missed I was reading other questions. Can you say that?
Sure. No, we're talking about predictive analytics, just in general, Antonio. So what capabilities come to the table there? So once we've got the data, we're pulling it out of the twin, what can we do with it?
Mm-hmm. Well, to make an example, the Ansaldo Energia project is focused on predictive analytics, where we have under control a full area of production of turbine blades, and the scope of the whole project is to implement predictive maintenance and predictive quality, looking at the high-speed data of the activities and of the operations of machines to understand failures or predicted failures of the machine, and B is to match quality controls with the actual history of the machine activities. It's a long way. It takes time. I think myself, I am much more fan of predictive quality, simply because it's much faster to find results in terms of matching actual situations. Because if the machine doesn't break, you never find out whether you have a prediction of a failure. But if you have a non-compliant component, this is something really frequent. You can understand the reasons why, and so actually implementing a solution to reduce the amount of non-compliances. But we have also other experiences using different technologies, including audio analytics, and regarding indeed, I think much more effective in quality prediction, in product quality analysis. And regarding predictive maintenance, really, if you have 1 year of data and in 1 year the machine doesn't break, well, what happens? You never know. And this is a problem. So it's something, structural, let's say.
Good point, Antonio. Thank you.
Yeah. And then on the cloud side, yeah, we have some partners in predictive maintenance. I think it's an area where people misunderstand quite a lot about what can and can't be done. The idea is you get data from electric motors all over 1,000 electric motors. You feed it through an algorithm. The algorithm learns how those electric motors work and then starts to predict when they're going to fail. To Antonio's point, that's hard to do if you don't have failing electric motor data to work from, which most facilities don't let their electric motors fail because it's too expensive. They replace them long before they're going to fail. So that data is actually quite hard to come by. Something we're exploring, and I'll just put this out as it's still something we are just now getting into, is what's called unsupervised machine learning. And this is a whole new branch. The idea there is there's patterns of operation during any piece of machinery. Say it's got a temperature, pressure, humidity, RPM, vibration. There are certain patterns that come off that piece of machinery. And if those patterns change dramatically, something's going on. And there is it's a branch called unsupervised machine learning. All you do is feed that data into an algorithm, and the algorithm says, okay, patterns are normal, patterns are normal, patterns are normal, patterns have changed, something's happened. That's something we're looking into.
Fascinating. I think that's an emerging area to stay tuned on.
Brand new. That one's brand new.
Yeah. No, absolutely. Just a reminder to everyone too, if you can, submit your questions in the Q&A window and not the chat, because I'm actively scanning the Q&A to get to the questions, and I may miss them if they pop up in the chat. If you've just got a general comment, feel free to put it in the chat. If you could put the questions in the Q&A. I'd like to jump on. I'm going to try and combine two questions, gentlemen. Michelle's raising one, and Ed has got a tangentially tied to it. The main issues to consider with the digital twin environment in terms of cybersecurity and data protection. If we could comment on that. And Ed's asking specifically, if the processing is happening in the cloud, more of it's happening in the cloud versus the edge, how are you mitigating the lag time and the latency issues to make sure that everything's still staying copacetic in the operational aspects?
Okay, so I'll take the latency. As long as your internet connection is decent, latencies between the cloud and the edge are kind of, maybe a second and a half. So if there's something real, high precision, you're trying to control a drill bit remotely, yeah, that's a problem. And that's built into the internet. There's nothing you can do about that. But as long as a second and a half latency is okay, if you need less than that, you need to do processing at the edge to reduce the latency. You can't handle, the cloud can't handle much less than that. Security is not really my area, but I think, Antonio, you probably have some good stuff you can talk about.
Regarding security, I have several answers given to some of the questions regarding cybersecurity and privacy. As I wrote before, if the question is, are our cloud applications secure? I would say definitely are more secure. What you have in a cloud than what you have in the factory is much more complex to secure factory environment, so the OT environment, rather than the cloud side. So because the factory, it's a mess, starting from the networking down to the operating systems. You have we installed things on Windows NT. So think about that, and we talk about cybersecurity. So basically, you have to make up a good IoT architecture, secure architecture, and then let's say the cloud will be probably the more secure part of it. Regarding privacy, as I showed before, we can ensure per variable, per connection, data distribution. So information access control is fully implemented, addressable. And of course, people discover that once you connect a machine to something, well, the machine is connected. And so there is a network, and the network is connected to other things. And so there is a whole, architecture and organization project to take care of that regards the networking, the asset management, including version control and many other things have to be done in on the OT side. That is normal for the IT, but is not so usual on the OT side. Think about that we have projects where machines get upgraded without the IoT people knowing about it. Not good thing, but happens simply because people and procedures are not fully fully tight to do that.
Wojciech is asking about confidentiality of the gathered data. So we talked a little bit about security, but I mean, anything you could mention in terms of confidentiality?
Yeah, so although we store the data, we don't own the data, it belongs to the customer. So it's really the customer has to, the user of the data has to come up with procedures and cover, if it's HIPAA compliant, they have to be HIPAA compliant. We're using either AWS Cloud or Google Cloud. They provide all the security and confidentiality tools, but it's really up to the user to define how those tools are to use. So if they want to be HIPAA compliant, if they want to not gather personal data, for us, it's just data. We don't worry about confidentiality. We don't own it, we just store it.
Got it. Benjamin's asking an interesting perspective. He said the example that you showed, John, had a specific location in mind, although it was fairly spread out. It was a facility. But do you offer any type of distributed location or geo mapping, either now or looking forward? UrsaLeo?
Yeah. So we have a customer that has 2,000 sites across North America. So there's a layer before you get to the model where you're looking at more of a map of North America, and then you zoom in, and then the 3D twin of that specific location comes up. That's fairly trivial to do.
Got it. Okay, very good. Jay has a question. This is, are APIs available for artificial intelligence and machine language driven control systems, especially model parallel implementations? And then what container runtimes are supported?
Wow.
That's a little bit of a weeds question. But
deep dive. Yes, APIs are available. We have both WebSocket and polling. I'm trying to remember the name of the polling API, the standard one. So yes, API is absolutely documented in and out. In is typically for bringing data in from other IoT systems, maintenance records, and then we can provide the data out for machine learning algorithms. We run in containers, so with Docker containers and Kubernetes. I didn't understand the last part about versions and stuff, and that would be a follow-on question for our engineers.
Fair enough. Well, if you need further elaboration, Jay, reach out, and I'm sure we can get someone back in touch with you post-conference.
Sorry, REST API and WebSockets. That's the two API types.
Got it. Thomas has got a question, and I'll try to stay agnostic once again. But he's saying, is it possible to easily jump in with something like SketchUp or a similar for making a 3D model, and then combine it with other types of software?
Yeah, SketchUp's a common one from an architectural point of view. We kind of have a list of file formats we prefer. So, CAD, AutoCAD is higher on the list. Revit's high on the list because that provides things like lighting and texture as well as just the model. Then you go down, to OBJ files, SketchUp files. There's a whole bunch and many tools out there to convert from one to the other. There's maybe more work involved than others because we have to add texture and lighting if it doesn't come with the file.
Got it. Okay. Now Benjamin's asking, he says, how easy is it to map and build a basic, reasonably realistic floor model and link to the Alientia software? And is there a DIY model? So he's looking to do it himself, or is this something that you folks come in and do it with the client? Maybe talk to that a little bit.
So we'd love to get it to DIY. It's not there yet. There's internal stuff we have to do that. You kind of need to be a Unity programmer and live and breathe the 3D world a little bit to be able to drive all the tools. But these are just off-the-shelf tools. They're not. There's nothing. There's nothing super proprietary there. So we'd love to get it to DIY. I think that's that's a slightly longer-term goal. Maybe not this year, maybe next year type thing. In the meantime, generating these models is real quick and very inexpensive. So we often get customers up and running for a few $1,000s with their first models and real data. Sub $10,000 in most cases.
Got it.
Regarding Aliantia, well, it's designed to be do it yourself, but of course there are different levels of I would say practicing or mastering. So there are certain things I don't know how to do myself, but one of my guys, they know it. So yes, but simplicity for us is very important, simply because this is stuff that has to be used by technology guys, so OT guys that are they need simplicity, they need to go fast because they have to produce. So not much of programming and details and quick things done quick and well. So that's the way.
I can speak to that, by the way. I went from downloading the Aliantia software to sending data to the cloud less than an hour. And I'm not super tech. I'm okay, but I'm not an IoT technician or engineer. But a few clicks, watch the online documentation, and we were up and running.
Got it. So much like home improvement, it's manageable depending on the skill level. So got it. All right, thank you for the responses, gents. Okay, Gustavo is asking, is there an integration of digital twins with devices or like RealWear, HMT, or other, I guess, other manufacturers' products?
So RealWear is definitely one of our partners. I didn't recognize the other one. I think it might be in a VR headset. I wasn't entirely sure. But yeah,
Okay.
we've got a list of platforms we're integrating, and RealWear is high on that list. On the VR side, it's going to be Oculus and then HoloLens, I think, are the two top ones. But if there's a customer need, an integration with a new platform is not a massive task. Obviously, going from not having voice control to having voice control, that takes a little bit longer. That's why RealWear is going to take a little bit of time.
Got it. Okay, Jay's asking, in terms of security compliance, are options available for enclave network implementations, like Department of Defense or IC clients?
Above my pay grade, I would have to refer to our security expert Ian Kansky, and he comes from that world. So
Okay.
that would be an offline question, and if I can get the details, then I'll get an answer.
Certainly. All right. Well, Jay, we'll circle back with you post-conference on that one.
For our side, it's in plan to do certification. I'm not sure whether we may be able to be certified for U.S. Department of Defense, as is not being American. So this is a question, but anyway, yeah, it's in the plan to be certified by, also by third party about software and solution.
Got it.
We've been security audited. I'd hesitate to say exactly what security levels we meet.
Understood. Right. Rightly so. We'll take that one offline then. Rob, thank you for the kudos. Rob's asking if we could elaborate maybe a little bit more on the the oil patch project, or the oil and gas sector project. Mm-hmm. If you could maybe.
Yeah, so one of our early adopters was an oil and gas company. They actually make vapor recovery units. So these as gas is dissolved in oil as it's released, they want to capture that gas, compress it, and make it available for resale. So they've got a very distributed model. They've got thousands of sites across North America. So there we are doing digital twins of all the units. And so again, geomap, you can sort of dive into specific units. They're really driving a lot of the advanced visualization. So fluid flow was done for them specifically, although it's available for everyone else. They very often want to see which direction fluid and gas is flowing inside a pipe, how fast it's moving, be able to see that remotely. Volumetric heat maps is also for them. So this is where they're using thermal cameras to track methane emissions. So not surprisingly, leaking methane into the atmosphere is not seen as a good thing these days. And lots of US states are implementing regulations around, not allowing you to do that. The way you capture methane emissions is thermal cameras. They use drones, mapping that into our environment on a volumetric heat map, so we can show where gas is and how dense. And then on-site safety, so tracking people on-site because they're out in the middle of North Dakota. So it's good to know that they haven't fallen over and are lying on the ground, not moving. That's obviously good information to be able to have. Remote maintenance for them. And then next year, they'd like to move all the way to remote control, where somebody's using virtual reality to stand in front of what looks like a piece of machinery, is using haptic gloves to press buttons and push levers, and that is controlling a unit that's hundreds of miles away in the field. So there's a list of things to do there, but oil and gas is a enthusiastic adopter of this technology.
You can see why. They have a lot of assets in very remote locations. Makes a lot of sense. Gershinen's asking for some insight on, we've talked about oil and gas, and we've looked at the industrial perspective, but any foresight for the agricultural sector, or maybe other areas that you could allude to, John?
Yeah, so the other one we have a lot of activity in is construction. Again, wearables on a construction site. Collaboration when you're on a construction site, very often you need to ask the project manager a quick question. Very convenient to have live video chat to be able to ask that question, without having to pull him on site. So we already have projects going on in the construction industry. We've had inquiries in agriculture. We haven't done anything yet. We've had fish farms, grain silos. I mean, the grain silo is really just a small manufacturing facility. Food processing, definitely. Medical would probably be the other area we've seen activity. So inside a hospital these days, tons of equipment that can be connected, tracking people, tracking if patients have fallen over, Hospitals lose equipment a lot, surprisingly. They actually don't know where equipment is a lot of the time because it moves around. So being able to track where equipment is a big thing for them. Medical this year obviously hasn't been, nobody's been looking at doing anything except surviving the year. So medical started at the beginning of the year and then stalled out pretty much.
God, there's some exciting frontiers there to embark upon. I mean, it's fantastic. Reddick's asking, what about combinations of RTLS and 3D models of plants, dynamic position 3D assets, and 3D models of shop floor?
I didn't get the RTLS reference, but everything else is what we do.
Okay. So maybe if you can elaborate, Reddick, what specifically you're asking about, we'll take another kick at that one. Let's see. So how would, maybe let's take a step back for a second. How can an organization get started with this type of an implementation, if you will? And I know there's a ton of the 800-pound gorillas out there, but maybe if it's a smaller organization, what's the first steps, John? How do they get engaged in something like this?
So our recommendation is we engage on something small. So let's pick, a couple of pieces of machinery or a small area of a factory, and let's generate a model, get the model deployed, get the real-time sensor data, get the other systems, maybe a maintenance records you want to pull into the model. And that can be done, very quickly and pretty inexpensively. So that's a great way to prove it out, show it to everyone else internally. So, your sales and marketing team will probably get excited because it gives them another way to show off their capabilities, quality control, the maintenance guys, the operation guys, the finance people love it because they can see ways that, it's going to save money. But that sort of projects, very often we're doing that for sub $10,000 to get something like that up and running. From there, obviously, we then look at a bigger project.
Scale it.
Yeah.
Okay, that makes sense.
Try not to do a whole 100,000 square foot factory right out of the gate. It's probably a good idea.
But I think the point being is this is approachable for a small manufacturer, a small facility. It's not.
Yeah, we've got customers. Their revenue is probably $50 million or less doing stuff with us.
Got it. Rashid's asking a question. He says, what metrics do you use for data quality from the IoT devices?
Antonio, over to you.
Yeah, I was answering actually. We have a logic that is, so we have the polling side from the device, and then if the device is detected not to be connected, not reachable for a polling cycle, then the data will be, as we keep the data of the last reading, the data will be marked as quality false. And so at the end, the application, so UrsaLeo will receive the data, but will have a mark that says, I give you the data, but I'm not sure whether the data are correct because I was not able to reach the device in the last polling cycle. Once the device is reachable again, then the data will have quality true. And this depends, the policy depends on how you have set the polling period in the device, on the device side.
Got it. Thank you, Antonio. Dave's asking more high-level questions. Is how does the deep learning work?
Is he talking about the unsupervised stuff that I mentioned, or is he talking about something else?
Dave, let us know specifically what you're asking about, because I didn't see when this question popped up, so I lost the timeline of when it came up in the conversation. So please circle back in if you're still with us and let us know about that one.
I mean, I can answer for both if you're interested, but maybe it'd be better to get a more specific question.
Got it. Okay. Let's see. Jay's got one. This is the unsupervised ML implementation and anomaly detection specifically are APIs amenable to reinforcement learning agents?
So the first bit I understand. The second bit I'm not an ML expert, so I'd have to take that one offline as well. But the first one, remind me the question again. Sorry, apologize.
Is the unsupervised ML implementation and anomaly detection? He's asking specifically about the APIs.
Yeah, so yes, it is an anomaly detection. What it does is it trains itself on, during normal operation, it detects patterns. And say you've got 4 sensors on the piece of machinery, it's going to detect 300-400 different patterns of operation. So it trains on each individual piece of machinery, not across all the types of machinery of the same type. So, the nice thing about it, one piece of machinery is in a cold environment, another piece of machinery is in a hot environment, doesn't matter. Each piece of machinery has its own patterns that the machine learning recognizes. You then set a threshold and you say, okay, if I see a pattern that's 1 standard deviation, 2 standard deviations away from standard operation, throw me an anomaly. It's not going to tell you what's gone wrong. It's just going to tell you that something weird's happening.
Got it. Okay, so something's rotten in Denmark.
I don't understand the APIs and stuff. I'll have to take offline.
Fair enough. Well, circle back, Jay, please. If you want a little bit more elaboration on that, we're happy to do it. Maybe talk a little bit about the models themselves and how they're maintained and or updated on any type of a periodic basis.
Yeah, so obviously CAD files, if the CAD's redesigned, we just need the new CAD files to generate a new model. If things move around inside the factory or whatever, we can make those changes very, very quickly. Our goal is in about a year or so to have customers be able to do that themselves. So say a conveyor belt moves from one side of the factory to the other, you'll be able to click of a mouse and drag it. We're not there yet. If you have Unity gaming skills on staff, then you can do it yourself. You just need to be able to drive the Unity editor. But yeah, it's pretty simple. I mean, like I say, these tools are incredibly widely used. So there's a huge pool of people out there who are very familiar with them, and eventually we'll make it so you don't have to be a Unity programmer to do it. But at the moment, it's anybody who can drive the Unity editor can make the changes. New CAD files, we just run those new CAD files through the system. Eventually, we'd like to have another layer on top that means that non-Unity programmers can make changes.
Makes sense. Magdalena just has a question more on the build space. She says, do you work with BIM, building information models, created in Autodesk, Revit?
Yeah, so that's actually a very good question, very interesting question. And the answer is yes, we're getting into that right now. So we're sort of another piece that plugs into the BIM model. So the BIM model is the Revit design, which is the actual architecture. Then it's all the records and the quote, the records, the documentation, everything that goes into that building, sort of pulled into one place. An Autodesk is BIM 360. Autodesk's tool is one of the very commonly used ones. So we would plug into that BIM model, and we would add things like records of the construction going on. So as you walk through the site and take scans as the construction's happening, we would add that to the BIM model. We would add real-time stuff to the BIM model. But absolutely, yes, integrating with BIM is as we get into the construction industry, something we'll be doing.
Perfect. Well, thanks for the question, Magdalena. Thomas has got an interesting one, actually. So real world perspective, do you consider use cases for escalations? So what do you do if you've got something that's out there pinging an alarm? It hasn't been handled in a certain amount of time. Is there some type of an escalation structure in the software?
We can easily add one. I mean, visualizations are simple to do. So if you want something to flash yellow, and then if it gets more urgent, it flashes orange, and if it gets more urgent, it flashes red, and the sound goes off. Yeah, that stuff's easy to do.
All right, perfect. Some good questions coming in, definitely. Giovanni's asking about connections between 3D and hypercloud. Is that something that you folks do too?
Man, I've heard of hypercloud, and I'd have to ask
sure.
them to remind me what hypercloud is.
Okay. So give us some more info, Giovanni, and we'll find out if hypercloud is an option for us. All right, so it's about 12:25. So I am going to, at least our local time here, Eastern Standard, we've got our award coming up. So I don't want to forget about our two winners before the session comes to an end here. And we've got a lot of questions. For the folks, we haven't gotten to some of these questions, feel free. We're not over, and we will roll this over into social media and address these across Twitter. And for those of you that had questions, by all means, we're going to get back to you on some of these that needed a little bit deeper dive. So I believe we'll see here if we've got the ability to jump into our wheel of names, because we had a lot of people active today. So I'd love to see that. I think Lucian is trying to pull that up in the background here. So we're going to take everybody that was actively participating, asking questions, commenting. We're We're going to throw your names into a hat, or technically it's a wheel. we'll give that wheel a spin and see who the lucky winners are for our NXP ultralight based hardware kit.
Okay.
So first giveaway. All right, Lucian, go ahead. I'll let
Thank you, Greg. We're gonna go over to Wheel of Names, and basically I cut and paste the active user. So the first prize, which Greg just mentioned, it's gonna go out to, let's see, it looks like Benjamin will be the receiver of that particular one NXP ultralight based hardware kit. Now we'll go for the second one, which is a Raspberry Pi kit with 9 sensors, and do spin that again. All right, and that looks like it's going to Federico Milan. We'll get you in the email, and then the last prize, which is going back to the Alentia's giveaway with developer license for 12 months. And we'll use the same technique there. Let's go ahead and click. So you'll be in touch via email. That's going out to Dirk from. So we'll touch base via email there to put you in touch with the sponsors. Thank you to sponsors. Thank you all for joining. Back to you, Greg.
All right, thanks, Lucian. So rest assured, we will reach out shortly, get the winners the prizes that they have so dutifully won by participation today. So before we wrap it up here, I think we've got a couple minutes left. Let's give our questions a quick scan here, see if there's anything else remaining that we can catch in short order. A lot of questions around software compatibility, so I'm not going to jump into any of those specifically. It sounds like, John, maybe you want to reiterate one more time. I think you've got a compatibility chart, correct, that shows what you guys currently are set up to deal with or interface with, correct?
Yeah, so in the 3D world, most standard packages have file formats that can be interchanged. So they almost all export into OBJ files or FBX files, which we can use. So unless you're using something really crazy weird, it's compatible.
Perfect. Well, there you heard it. All right. Well, I think that probably brings us to the end of our session today. So I want to thank everyone for taking the time to join us today. It's fantastic content. I mean, I think this is an emerging area, and I think you're going to see a lot of exciting things coming out from all three of these organizations around the whole concept of the evolving 3D virtual twin arena. Invite you to all please take a look at our events page to see what's coming up in the coming months. Other events, we have January 21st, we have an event on supply chain, and stay tuned for that one. And then March 18th, we have an IIoT World Manufacturing Day focus. So this is going to be similar to the events that we've had in the past. We had October 22nd, we had a cybersecurity focused event. And we had one back in June, which was a full industry vertical, all 2-day event. So this Manufacturing Day event will be a full day. Stay tuned for that. And I believe the folks here from UrsaLeo will be joining us for that as well. Special thanks to the sponsor today, UrsaLeo, for this educational session, and to our speakers, Antonio, John, and Gabriel. It's outstanding content. Thank you all for joining. If you have a suggestion for a topic or otherwise, we always welcome feedback, so please feel free to drop us a message and let us know. And if you like what you heard today, we'd invite you to subscribe to our YouTube channel, our website, and our newsletters. And you can follow us at IIoT_world. This concludes today's program. I want to thank everyone for joining us.
Thank you.
Thank you, guys.